Good morning to you, ladies and gentlemen. I truly respect what I have just heard from these two speakers, Alexis and Richard. They were quality talks. Thank you very much indeed, both of you. And they basically told you my message, which is that solar is suboptimal here in Hong Kong. But let me go through it from my standpoint. First of all, I'd like to say thank you all for coming. I know it takes time out of your day, and I appreciate you taking that time. And also I'd like to say thank you very much indeed to the Civic Exchange for inviting me to speak. The subject of my talk is the rollout of solar technologies in southern China. How realistic and how soon? I'm going to start at the top level, which is the global level, describing the attractions of solar energy. And then stage by stage, I'm going to bring you down to the national level and the regional level. And hopefully by the end, you will have a realistic understanding of the potential for the rollout of solar energy in the PRD. The world's economic and industrial system is based on the availability and use of energy. When we consider the choice of energy supply that's available, we're faced basically with three choices: fossil, nuclear, and renewable. The energy system of today is based mainly on non-renewable fossil energy, and that's because it has been the most scalable energy source up until now. Is that better? Okay. Okay, thank you very much. However, as has been now, first of all, fossil fuel has been the most scalable energy source to date. Nuclear is going to prove to be the most scalable alternative to fossil fuel in the near future. Renewable energy is limited in its scalability for the reasons that has been so elegantly described to us by the two previous speakers. Each renewable resource has a specific geographic distribution. Now, the problem that we face today is how do we rebalance the use of energy between these three sources, whilst at the same time not reducing economic welfare. So, why solar energy? Quite simply, solar energy is abundant and it's free. But how abundant is it? I've got some simplified figures here, but on the supply side of the sun, we're looking at the sun's average, looking at the sun's average radiation density flux of 343 watts per square meters. That's what's coming out of the sun. 70% is absorbed at the Earth, and about 30% more is taken out by the time it reaches the surface. Now, that means that we get 165 watts per square meter when it hits the surface here, on average, across the whole of the Earth. Mankind's energy density flux, in other words, the amount of energy that he uses, is only 0.03 watts per square meter. Therefore, the amount of flux that is received at the Earth's surface is over 5,000 times more than the energy which man currently uses. Therefore, the challenge of the 21st century is going to be, how do we capture 1/5000th of the sun's power here on Earth? I'm going to put this set of figures in a different form. Up here, we've got a series of cubes. Up here on the top cube, this is the annual global energy consumption of 2005. And it's sitting on top of another cube, which is the proven gas reserves, and another cube, which is the proven oil reserves, and another cube, which is the proven coal reserves of the world. Now, that will mean that that number of cubes will fit into this, and it'll take several decades before you can eat up all of the other cubes. But the big cube here at the bottom represents just 1 year's worth of solar energy that hits the Earth. And so the key thing here is that we have to harness solar energy. The solution to the world's energy need is obviously solar energy. The problem is, how do we convert it? How do we retain it to suit our needs? There are 4 basic problems. First of all, capture, conversion, storage, and delivery. The best availability of the sun is in the tropics, near the equator, north and south, 30 degrees. And the most usage of electricity, as we know, is outside the tropics, in temperate climates. So there's a mismatch between best supply and most demand. The optimal solution, therefore, is to capture and convert solar energy in the tropics, in the best centers of production, and then store and transmit it to the main centers of demand. In the fossil fuel-centric world of today, we've learned how to transport huge quantities of oil, gas, and coal to the centers of demand. What we've got to learn is how to transmit solar-generated electricity from the best place of capture over long distances to where it will be used. And this really is an on-grid solution. But for this on-grid solution to work, not only must the energy be available from a secure source, but also the energy must be available in a form that guarantees grid stability. In other words, it doesn't vary in large quantities. And so therefore, the key problem facing renewable energy is to balance out the irregularities in the current. It's also possible to achieve off-grid solutions, and this means local capture, and that has been discussed by Richard in the previous talk. However, local capture is unpredictable, it's seasonal, and it's subject to natural factors such as the weather, air pollution, sun hours, spectrum captured, humidity, and vegetation. It also poses problems of stability on the grid. Now, we've already seen from Alexis, or from Andrew, I beg your pardon, the distribution of solar resources around the world. Basically, the best places to capture solar is where it is red on the map here. That's in the middle of the dry deserts. So here, and here. Moving out from that into the orange area, that is less beneficial. And then out into the pink bits here, or light orange bits, that's where you'll get a suntan. But the gray bits is where you won't get a suntan. All right? So China is reasonably well endowed. It's reasonably well endowed, but it's not optimal. And the best of the potential in China, as we saw from earlier slides, is in the northwest of China, rather more than on the coast. I'm going to take a slight detour at the moment, and I'm going to take a look at the greatest solar potential in the world, and that's sitting in the Sahara Desert. A study has been underway since 2003 into the deployment of concentrated solar power, and you saw a picture of one version of that from Richard's presentation in the Sahara Desert. And this is called the Desertec concept. Under this concept, the solar energy was going to be captured in the Sahara and is then going to be transmitted to Europe for consumption. The final draft of the paper was published in March 2009, and I do suggest that you try and read it. The concept states that if CSP, that's concentrated solar power, was deployed at just today's efficiencies without any change in technology, just on 5% of the land mass of the Sahara, it could generate all the electricity consumed in the world in 2005. That is how good it is. And that's what this red square is there. That is just the area on the Sahara Desert that would be needed to be built on just to provide all the electricity needed in the world today. The bit down below is for the European community, and the bit below that is the Middle East and North Africa. So, in other words, desert-based concentrated solar power has the potential to replace all the world's existing capacities of balancing power. Now, why did I divert to talk about the Sahara Desert? Well, if you sort of look at the line of latitude that is there, that is the same latitude as Hong Kong. We're on the same latitude as the Sahara Desert. So, in theory, the angle of the sun is exactly the same here as it is in the Sahara Desert. But why cannot Hong Kong rival this concept? Well, Alexis has told us. We've got weather, we've got air pollution, we've got fewer sun hours. This place is suboptimal to do solar power. There are two types of solar power that are used. One is called solar thermal, and the other one is called solar photovoltaic. In March this year, the International Energy Agency published a report called the Solar Heat Worldwide 2009. And this is the first major report indicating the deployment of solar thermal heating around the world. And this deployment is summarized in this diagram. What we find is that solar thermal heating, that's this area here, is second only to wind power in the production of renewable energy. Please note that the amount of energy produced, that's the red column, as opposed to the blue column, which is the capacity installed. Please note that the energy produced by solar thermal heating per unit of installed capacity is much lower than for wind power. That's your capacity, that's your amount of output. And the reason for that, quite obviously, is that solar power does not operate after dark, and wind power does. Please also note that here, geothermal power, this is the most reliable source of renewable energy. Just for this amount of installed capacity, you get 6 times the amount of output. Now, the International Energy Agency has made a calculation in respect of this amount of energy output that the contribution of installed hot water collectors to the global energy supply is the equivalent of an oil equivalent of 12.1 million tons of oil and a CO2 reduction of about 39 million tons. So we already have a very large installed capacity in the world of solar thermal at this time. Now, where does China fit into solar thermal? This rather busy graph here doesn't do justice to China. China is number one. It's out here, and you can see there's a breakpoint on the graph. If we focus on the total capacity of all flat plate and evacuated tube solar collectors in the world today, as at the end of 2007, we find that the world leader is China, and it represents 66% of the world's installed capacity of solar thermal. That's the equivalent of 79.9 gigawatt thermal. In addition, China is aggressively rolling out more new solar heating capacity than any other country. So in this period, which is 2007, it actually went from 64 to 66%. So therefore, it's increasing its market share in the world by 2% per annum because of the aggressiveness of its rollout. Now, the other countries that come in behind it are Turkey, Germany, Japan, and Israel. So how is China using thermal solar? This is from the same report, and it shows you how different countries around the world have installed what new capacity they installed in 2007. This is China here. Based on 2007 figures, China's deployment of new installations of solar thermal splits about 50% to single-family dwellings, 25% to multifamily dwellings, and 25% to hotels and tourist centers. This recognizes that the majority of energy that we use in our buildings is for hot water and space heating. And it is this, and just bear in mind that we're going to be looking at hot water and space heating going forward. How has China developed solar energy in the past? Well, based on these figures, it's obvious that China has already undertaken widespread adoption of solar energy for water and space heating. There's a company called Haimin Solar Energy, which is based up in Shandong province, which accounts for 10% of the total output of solar thermal collectors in China. And that company, just one company, puts out more output of collectors than are installed in the whole of the European community, and twice what's installed in the United States in 1 year. And so China is dominant in this area. But there is another area which is concentrated solar power. China signed a heads of agreement back in 2006 with a German company called Solar Millennium to install 200 megawatts of concentrated solar in Inner Mongolia. And that was supposed to be in operation by 2010, but it doesn't look as though it will be. And within the 11th five-year plan, the current five-year plan, the target was to install 300 megawatts. So just this one plant would have installed 200 of the 300, in other words, two-thirds of the planned capacity in solar in concentrated solar. In photovoltaics, private companies in China have focused on PV cell manufacture. However, the government has not until earlier this year created a program of subsidies for the installation of PV. So in the absence of a domestic market, the PV companies have been 98% for all their, dependent for all their sales on exports. Now, as we know, at the back end of last year, we had a global financial crisis, and the funding of solar projects has collapsed. And so over 50% of China's PV module makers have stopped production as at December last year, and there are probably more today who have done so. So having looked at how China did in the past, what's China doing in the future? Well, the policy that is being put out by the NDRC is currently in limbo. They're defining their solar targets, and as Andrew put out in the first talk, there's an official versus an unofficial target. Undoubtedly, the large-scale rollout of solar water heaters will continue across the nation. 20 cities in China have made it mandatory, and 3 provinces have made it mandatory that all new buildings have these on board. But I'm sure it'll be rolled out across the whole system. Whilst the political will seems to be in position to expand concentrated solar and photovoltaics, its place in China's energy mix is unlikely to rival wind or biomass. You know, we've had indications of 1%, you know, just a few hundred megawatts in the system, and that is very, very small. China this year will roll out 80 gigawatts of coal-fired power stations, and that represents 1.5 gigawatts a week. To put in 150 megawatts or 200 megawatts of solar is a drop in the bucket by comparison. But let's see what they're doing in practice. In December 2008, Huaneng Power, one of the big 5 power producers, announced that it had started construction construction of a 166 megawatt solar plant in Yunnan province. In February this year, the China Academy of Sciences announced that it was going to construct what's called a thermal power tower. It's one form of concentrated solar power in Beijing. This is an experimental facility, and it seems that China is seeking to master this form of concentrated solar. If they do master it, we must expect that they will roll it out in scale. And in March 2009, they announced a policy for subsidies for photovoltaic, very, very positive subsidies. The subsidies in the scheme could be as high as 20 yuan or around $3 a watt, and but you have to have a minimum of 50 kilowatt capacity for installation, and also have a minimum 16% efficiency on these solar arrays. If such levels of subsidy would be put into position, all you'd have to pay for is actually the installation cost of the arrays. However, they then capped the amount of money that was available for this subsidy scheme to $60 million US, and that basically is the equivalent of putting one on each building in every province in China. It's not very big indeed. However, whilst PV may not be on the menu for this year, it may be on the menu in the future. Do not underestimate China. It's a disruptive market in energy. We've seen that in wind, we've seen that in oil, we've seen that in nuclear, and it may also be in solar PV that becomes a disruptive market. But quite frankly, such level of support for both solar thermal and PV is underwhelming. For now, the government has prioritized resources away from the solar sector. It doesn't mean to say it'll stay there, but for now it has prioritized resources away from solar. Where does Hong Kong fit into solar? In December 2002, the Electrical and Mechanical Services Department published a study on the potential applications of renewable energy in Hong Kong. It's a 240-page report. I suggest that you try and get a hold of it to read. Basically, the report states that the three biggest uses of electricity in Hong Kong are for space conditioning, lighting, and refrigeration. And the biggest uses of gas are for cooking and hot water. What applications could solar be applied to in Hong Kong? In the residential sector, solar water heaters do work in Hong Kong and could provide useful energy substitution. However, as we all know, the size of the average flat here in Hong Kong is little more than 400 square feet, and therefore the space that would be required to take up a tank is just too much to ask a family to give up. Only hospitals, hotels, and clubs and some sports facilities actually have centralized hot water systems, and these could be retrofitted to include solar water heating. If you remember, China made sure that 25% of its installations went into hotels and sports facilities. But here in Hong Kong, these facilities only account for 10% of total hot water consumption. And with hot water being only about 8% of Hong Kong's total energy consumption, full adoption by this group of users will do no more than reduce overall energy consumption by 1%. Therefore, the issue in Hong Kong is not one really of trying to install solar thermal. It really is one of changing building design so that the energy consumed by each building is reduced. Moving on to solar applications in commercial. In the commercial sector, the report estimated that commercial building integrated photovoltaics, Richard touched on this, offer the potential to generate around 121 gigawatt hours per year, or just 0.3% of total 1999 annual electricity consumption. However, as Richard pointed out, and Alexis pointed out, the angle of the sun here in Hong Kong is such that the PV panels will have to project out from the sides of the building if they're to maximize efficiency. They will gather dust, and I'm sure that a gondola going down to wash the windows will knock them off. So really the potential to generate PV power here in Hong Kong would only equate to about 2% of the SAR's annual electricity consumption. So the net contribution of solar PV here in Hong Kong over the next decade can only be viewed as marginal. So Hong Kong is highly urbanized. It's one of the most compact cities in the world. And buildings account for the largest fraction of electricity consumption of all users in Hong Kong. If Hong Kong is to act as a role model for being a green city in Asia, it's easier to harness potential efficiencies to reduce a building's net energy demand than to actually use those buildings for solar power generation. But there is one area here in Hong Kong that could be where a quick payback on solar power could be useful, and that is in the area of street lighting. If we adopted low-consumption LED lights powered by solar panels, that could be helpful. What can be done in the Pearl River Delta? Well, we know that the Pearl River Delta is the greatest concentration of manufacturing industry in the world today. Furthermore, the speed of the rollout of that manufacturing base was achieved without compromise. The consequence of that has been accelerating environmental degradation, and I don't need to talk about that. And this is reflected in the readings of the Hong Kong Observatory, which show that the amount of insolation, that is, the amount of sun energy that comes through, has reduced by about 20% since 1970 due to the development of industry in the region. So how do we encourage greater energy and environmental efficiency here in the PRD? The World WWF, the Worldwide Fund for Nature, has just published its low-carbon manufacturing standards for use in the PRD. The WWF estimates that it's possible to achieve a reduction of 74 million tons of CO2 equivalent if this standard is fully met by all the factories in Guangdong. The adoption of the standard is voluntary, and the reward for adoption is that your products will be able to have a low-carbon manufacturing process label stuck on them so that when they turn up in shops in the European community or in the USA, people will know it's an ethical product. But as in Hong Kong, the amount of solar energy available for generation is not good. You've seen that on the various presentations. And therefore, the solution seems to be, in terms of energy efficiency, to actually improve buildings yet again. It's all about improving building thermal efficiencies to reduce power consumption. Now, there are global benchmarks emerging at this moment for building efficiency. With the upcoming climate change conference in Copenhagen in December, governments have begun to publish their long-range targets. The Japanese government, just on the 2nd of June, published its white paper in which it proposed measures to reduce CO2 emissions in residential areas by 85% by the year 2050 by using new building standards. In the USA, Energy Secretary Stephen Chu is on record at the end of May as saying that the first step in America should be a massive program of efficiency for commercial buildings with the target of saving 80% of their energy use by 2050. And the US federal government is working to improve those standards. And so, moving on lastly, what is the PRD as a manufacturing center for solar applications? With China's main power engineering firms based in the Bohai Rim, in Shanghai and down in Chongqing, it's unlikely that the PRD will become anything other than a satellite manufacturing center for solar applications. However, there is one technology that is relevant to solar, which is located in the PRD, where China leads in the world, and that is in the areas of batteries and storage. There's a company called BYD Electronics, based in Shenzhen, which is a world leader in batteries. And so, coming to a close, the rollout of solar technologies in southern China, how realistic and how soon? China will remain the world leader in solar thermal for space heating and space conditioning. They will continue to roll out all of this program across China in accordance with the government's guidelines. China is unlikely to use solar concentrated and PV for utility-scale electricity generation down here in the PRD because of the lack of availability of the solar resource. However, instead, the government is showing a clear preference to locate utility-scale concentrated solar and photovoltaic up in the northwest of China, where conditions are best for solar capture. This means that solar power will have to be fed into the grid, and as we know, there's big wind up there, there's big gas up there, there's big solar up there. We're basically seeing the construction of energy corridors from the northwest of China to Beijing, to Shanghai, to Guangdong. China is rapidly becoming a world leader in high-voltage direct current transmission systems. And so the PRD will receive its solar energy transmitted over long distance from far away. By realizing that the central government is unlikely to support a widespread adoption of CSP and PV in the PRD for the time being, the most realistic response to the large quantities of irradiation, that's incoming solar radiation, to the region is to lower the consumption of electricity by improving building efficiencies. Thank you very much indeed for your time.
Testing, test.